Does Earth rotation affect air travel? If Earth were spinning, wouldn't there be an actual Coriolis effect on airplane flights, north and south? How much does the speed of rotation change in, say, 10 degrees? Would a pilot have to factor Earth rotation into his navigation? Let's review the spinning globe claim. Earth is 24,901 miles at the equator. If it rotates once each 24 hours, then the speed is 1,038 miles per hour at the equator, or 0 degrees latitude. However, in that case, at 31 degrees north, the speed is 890 miles per hour, and at 41 degrees north, the speed is 775 miles per hour. That means the difference in speed between 41 degrees north and 31 degrees north is 115 miles per hour. Let's take a virtual flight and see what would happen. We will fly from South Bend, Indiana at 41.67 degrees north to Mobile, Alabama at 30.96 degrees north. Our airplane will be a Cessna 182 Skylane. It flies at 145 knots or 167 miles per hour and carries 4 people. South Bend to Mobile is 770 miles. At 167 miles per hour, it will take about 4.5 hours. Our heading to Mobile is 189 degrees. How does a pilot maintain the 189-degree track? What about a crosswind blowing the plane off course? The most basic method is called pilotage. There are large and very detailed charts called sectional charts, which have symbols depicting airports, towns, roads, railroads, rivers, towers, and golf courses, because all these can be easily seen from the air. A pilot can look at these charts and see his departure airport and all places along the route of flight. So long as he passes over those locations, he will arrive at the destination. So here's our Skylane, about 12 miles on course to Mobile. On our left, in the green circle, we see a maroon flag. That is a golf course. On the right is another golf course. So we know we're on track. If there is a crosswind, the pilot can turn into that wind a little and maintain the same heading track. For a flight from South Bend to Mobile, Alabama, the ground track is 189 degrees, always. Nowadays, the data of our charts can be combined with position and location of your airplane, and the pilot can easily stay on course and see exactly where to fly in order to stay on the correct ground track. This navigation information is provided by radio signals from ground-based towers and displayed data to allow the pilot to remain or return to the correct ground track. But in all cases, the ground track to the destination never changes during the flight. The truth is, if our flight starts on a 189-degree track and stays close to that track, after about 4.5 hours, the navigation display will look like this. Our flight will be on final for Mobile, Alabama Regional Airport. Our Skylane will touch down with no problem at all, and no pilot and no navigation equipment made any compensation for the spin of the Earth. Now, if the Earth spins, then these are the actual speeds. South Bend would be moving east at 775 miles per hour. And since we feel nothing, that means our Skylane is moving east at 775 miles per hour also. But Mobile would be moving east at 890 miles per hour. This is the globe theory. That means Mobile would be moving 115 miles east of our flight path each hour. If Earth was spinning, then our flight would be 517 miles northwest of Mobile and 70 miles northeast of Dallas, Texas. But that never happens because the Earth is not moving, and air travel proves it. Thank you.